So there are 3 tasks today. Some of you will have already completed task 1 because that was all about solving simultaneous equations. This is still about solving simultaneous equations, but this is kind of our step between simultaneous equations and what we're going to do next, which is line intersections. You have 2 equations here, and I've asked you to solve them simultaneously. But if we write them down in a standard simultaneous equation way, we spot that there is a problem. And that problem is that the equal sign for one of them is here and the equal sign for the other is there. We'll get x's on this side and we've got x's over there. This isn't going to be helpful. So if we end up with this set up here, we probably want to rewrite our simultaneous equations. Now, it doesn't matter what order our y's and our x's come in, so I'm actually going to keep that top equation the same. On the bottom equation, I'm going to take the 7x off, so I'm going to get 2y minus 7x equals minus 3. So all I've done is taken 7x off both sides of that equation, and we get this. And these two now have y's lining up, x lining up, or equal sign lining up, so it looks like a normal pair of simultaneous equations. And so we can solve them in a normal way. So we'll number them 1 and 2. We will do 2 times equation 1. We'll do 3 times equation 2. Get that common multiple here. So that is 6y plus 8x equals 14. And down here, that is 6y minus 21x equals minus 9. Let's label that one 3 and 4. Right, we can work with that pair. So now we are going to do, now it's up to you, I'm going to try and keep my x's positive, so I'm going to do equation 3 take away equation 4. That take away, that's nothing. That take away, that 8x take away minus 21x gives me 29x. 14 take away minus 9 gives me 23. And so x equals 23 over 29. Now we can put that in. Now actually, if we look back up here, this equation here is the easiest thing to put that into. You can pick any of your equations here. I'm spotting that one looks easiest because it's y in terms of x. So put that into 2y equals 7x minus 3. Just stating which equation I'm putting it into so I can follow what I'm doing. So 2y equals 7 times 23 over 29. Take away 3. So 2y equals, now I've got to do a bit of annoying multiplying here. Yeah, that probably is the easiest way to do it. 7 23s are 140, plus 21 is 161 over 29. Take away, put that over 29. Well, 3 29s are 87, I believe. And so we now have 161 take away 87, which is, I should have done this in advance, 64. No, try that again, 74. Definitely should have checked this one in advance. 74 over 29, and that's 2y, and so a single y. Well, when we divide by 2, we could divide this top number by 2, is probably the easiest thing to do here. So we end up with 30, well, 70 divided by 2 is 35, plus 2 more is 37 over 29. Again, as we did before, we just want to state our answer. So we have x equals 23 over 29, y equals 37 over 29. Okay, I want to get you used to the idea that sometimes we get horrible answers out and you just have to learn to deal with them. Now, we're going to do another one that's very similar, and then I'm going to give you some to practice with, and hopefully on the second example you see where we're going with this. So this one here is our second example, and this second example looks very similar, but you'll spot that we've got 2 equations which are y equals 2. Now you might be thinking, I can see where you're going with this because these are line equations just like the ones we were working with before. So we've got line equations, and in a minute we'll in our third task for this week, we'll make a connection between line equations, simultaneous equations, what that's actually telling us. But let's start by putting them into that standard form. So the standard form that we were putting them into is something times plus something times x equals something on that side. So doing that to that, if we take 5x off both sides, we get y, take away 5x equals 4, sorry. Well, plus not an equals. The second equation takes a little bit more rearranging. In fact, you might want to do a little bit of up here. Multiplying everything by 3, we get 3y equals 2x, and don't forget to multiply that 8 by 3, so we get 24. Now taking 2x off both sides, we get 3y minus 2x equals 24. So we've just taken our two equations, we've rewritten them into a much more standard simultaneous equations form. If you're multiplying by the bottom line, just remember to multiply everything by it. So that's where this bottom equation is coming from. Now, once we're at this point, we've just got two simultaneous equations to solve, and so we fall back into simultaneous equations mode. I'm going to multiply the top equation by 3, and the bottom equation can just stay the same. We don't need to change anything. So end up with 3y minus 15x equals 12, and 3y minus 2x equals 24. Equation 3 and equation 4. A bit of cunning thinking. If I do this equation, take away that one, we will end up with positive numbers, which is what I always like, because we're doing 3y take away 3y is nothing. Minus 2 take away minus 15 is the same as minus 2 add 15. So we end up with 13x. 24 take away 12 is 12. So x equals 12 over 13. Let's say I'm not getting you too used to always getting nice numbers, because plenty of the numbers you'll have to work with at higher level are not nice numbers. You can choose where you put that back into. Like we did with the previous example, I would pick the simplest equation which we have, which is that one with y equals to something. That's probably going to make our life easier. So I'm going to put into, and the equation I'm putting it into is y equals 5x plus 4. And now we can do that. So y equals 5 times 12 over 13 plus 4. 5 12s are 60 over 13. 4 13s are 52 over 13. Adding these two together, we end up with 112 over 13. That was fine. Don't mind a top-heavy fraction as an answer. So we've got our answer, x equals 12 over 13, y equals 112 over 13. And there's our final answer that we've actually got. So that gives you a rough basic idea of where we're going with this. Simultaneous equations, but with equations which we need to do a bit of reorganizing to first. Have a go with these, get the practice in with these, and then we'll introduce our final idea, which is connecting this all to line equations and what's going on with those.